Okay, so in this video, we're going to demonstrate that S2 is not a unique operation. S2 is actually equal to inversion. So what do I mean by S? S2 is called the improper rotation axis. So a generic Sn is equal to a Cn followed by a sigma h. So you're going to do a rotation, and then you're going to do a horizontal mirror plane. And so if we think about what an S2 would do, well, first we would do a C2. So we can draw our axes, X, Y, and Z, and this is a rotation, and we always have our rotation as our principal rotation axis, our highest order n rotation in our molecule. In this case, we're assuming kind of this is the only rotation we have, is going to be defined as our Z vector. So we're doing C2, the C2 is going to be along the Z plane. So if we imagine, if we around this the Z axis, so if you imagine we have an X vector, we do a C2, C2 is 360 degrees over N rotation. N is 2 here, so over 2 rotation, 180 degrees rotation. That's gonna, this C2 is gonna spin us from X to negative X. And very similarly, a Y vector, we start out with a Y vector, that would spin us 180 degrees to negative Y. So if we started with some arbitrary point, X, Y, Z, and we went to, and we want to do a Sn, right? Well, we're going to do a C2 first. By the way, usually people use hat notation here on all of these just to show that these are operations and not symmetry classes and character tables. This is going to be a C2. So if we're going to do an S2, we're first going to do C2, and what we've found here is that takes negative X, X to negative X, Y to negative Y. What about a Z vector? Well, Z vector, if we did a rotation, 180 degree rotation on a Z vector, it's not going to change the direction of that vector. So Z is going to go to Z. But then next, our definition is that we're going to do a sigma H. So we do a C2 followed by a sigma H. And what is a sigma H? A sigma H is a horizontal mirror plane. So we just did a C2, and horizontal perpendicular to that C2 axis in our XY plane, right? Because our C2 axis went through here, as we defined as our Z axis. Our sigma H is going to be in the XY plane. So if we have a vector, Z vector, it's now looking at itself in the mirror plane when we do the horizontal mirror plane, and it's going to go to negative Z. So now we have negative X, negative Y, Z, and Z goes to negative Z. And what about an X vector or a Y vector? Well, those vectors are in the XY plane, they're in the mirror plane. So whenever a vector is in a mirror plane, it doesn't do anything. So X goes to X, and Y goes to Y. So we started with negative X, so we don't do anything to it. We just go to negative X. We start with negative Y, we don't do anything to it. But the mirror plane, the horizontal mirror plane, we figured out took these blue vectors took Z to negative Z. And so that is what doing an S2, how an S2 works. It takes X, Y, Z, any arbitrary point X, Y, Z, and goes to negative X, negative Y, negative Z. Well, that is the definition of inversion. And the definition of inversion is that you take any arbitrary point X, Y, and Z, goes to negative of themselves. So because these two are equal, an S2 is equal to inversion. So you'll never see S2 written out. Instead, you'll see inversion. S3s and any higher order Sn improper rotation axis, those are unique operations. They're different than any other symmetry operations that we have.